Welcome back. Today we are unlocking one of the most powerful ideas in algebra, system of equations, graphing. Because in math, every problem is a story. And the moment two lines cross, that's where the answer lies. We'll break it down into three simple cases. One solution when the lines intersect, no solution where the lines run parallel forever, infinitely many solutions when the lines are actually the same. And this isn't just a theory. We'll look at real-world examples, tickets, phone plans, and more, so you can see how intersections become the solution. So grab a pen, get your graph ready, and let's master the simplest way to solve a system of equations. Clear visuals, quick steps, and zero confusion. Let's jump in. This one is better for you, but another one said that no, I'm going to use it a lot, so the next one is going to be better for you. Maybe at some point you say that, oh my god, this is going to be costly at the beginning. Yes, but in the long run, it's going to be more economical for you itself. So there are some kind of pitfalls and some errors that could happen for you. You have to be very, very, very careful. Parallel is almost parallel. What does that mean? It means that if you have two lines and their m are not going to be exactly like each other, because I know some of you say that, okay, we like rounding. Rounding is not good at the time. Maybe sometimes it's good, but sometimes it's not. What does that mean? Imagine that I do have two m's. One of the m's is 2.57 and another one is 2. For example, 47. For some of you, they're going to round it up and make it at 3. For some of you, want to round it down or some kind of make it as 2.5 or whatever. I don't know. So at this point, you're missing something. Yes, 2.57 and 2.47 are very, very similar to each other. But you know for a fact, in the long run, they are going to have intersection because, again, their m is not simple, and you're going to make it worse by rounding it actually. 3 and 2 are going to be way, way off. So you're losing a point. Please try to be careful based on the question itself. For example, whenever they give you a question, at least this is the thing that I'm doing with my students, I will tell them that I need 2 decimal points. 3 is very some kind of rare. 1 decimal points. So try to keep them as the way they are. Try not to round them because you're going to ruin something. So be careful about that. After that is about the scaling. So try to some kind of be careful about the scaling. Sometimes it would happen about the mismatch with axis, and try to make all of them one by one, unified. After that, the sign errors, which is a very, very important part. So when you're talking about the slopes, when you're talking about the first interception or y-interception, try to make sure you completely aware of the positive and negative of the sign itself. There's some kind of tips for you. Try to some kind of zoom in or confirm algebraically and try to make sure that some kind of, because sometimes you do have non-integer intersection, 2.4, 2.5, negative 2.4. So make sure that you're zooming in, especially when you're talking about the graphic. Try to verify your answer always, whenever you find the x, because there's high chance for you, especially at the beginning, that you're missing something. So when you find the x, try not to only trust your final answer. Put that specific x inside both of those equations. y1 and y2 should be the same. On that point, you can say that, okay, I can use that right now. So please all the time double check it. And try to make sure about the equation are going to be in the correct form before graphing. I told you y is equals mx plus b for the first one and the second one as well. If you are following another format, make sure that the specific format is going to be the same for both of them, because at the end you're going to find the wrong number itself. And for the final section, we do have again 3 conditions. At one condition is when m's or the slopes are different, rise over lines are different. We know for a fact that both of those lines are going to have one intersection. After that, we do have no solution at all. It means that we do have 2 lines, their slopes are going to be the same, but their interception or y-interception is going to be different. We do have 2 parallel lines, and at the end, we do have infinite number of solutions. It means that with your lines, your equations related to lines are going to be completely equal. The m's and the y's are going to be, the m's and the b's are going to be the same itself. So right now, I do have a couple of quick practices for you. Try to pause the video Try to think about it. Again, look at some previous parts and completely understand it. And after that, solve this kind of questions. Doesn't matter how long it takes. Try to understand it. After that, solve this kind of questions, and we are going to solve them together. So right now, I do have 3 questions. And I'm going to solve all of them based on the equation wise. That will be better because we don't have the ruler and all of kind of equations right now, but you can do it by yourself. You can solve it based on equations, and you can use the graphic wise. So I do have 2 points. Y is equals half of x plus 2 and y is negative x plus 5. So the question is simple. Again, I'm trying to find the intersection point for all of them. I know for a fact that y is mx plus b, y is mx plus b. So since their m's are different, I know they're going to be different as well. So I do have one intersection, one and only one. So half of x plus 2 equals negative x plus 5. So what would happen? I have to move all of the x's in one side and all of the some kind of numbers in another side. So if I move x to this side, I do have 1.5x plus 2 is 5. If I move 2 to another side, I do have 1.5x is equals to be 3 itself. So if I ask you what is the number itself, the number x is going to be 2, right? I know for a fact that my x for both of them is going to be 2. So put the 2 in each of them to see that am I going to get the same y or not. If you put 2 over here, y is equals to 3. You can do it again, y is equals to 3, so that is my right answer. I do have 2 equations. Y is negative 2x plus 1, 2y is equals negative 4 subtracted by 6. So for a fact, I know for a fact that I have to make y is equals mx plus b. This one is okay, but this one is not. The only thing that I have to do, divide both sides by 2, so I do have y is negative 2x subtracted by 3. As you can see over here, the m's are the same, but they don't have the same b, so I don't have any intersection point. It means that these 2 lines are completely parallel. On another hand, I do have these 2. I do have 3x plus y is equals to 9. So if you adjust it and if you move the 3x to the right side, you have y is equals to 9 subtracted by 3x. I do the same over here. Your y is going to be what? Your y is going to be x subtracted y 1 itself. So I do have 1m as a positive 1 when you don't have a number that is 1, and I do have another one as negative 3. I know for a fact that these 2 are going to have one intersection. How I can find it? X minus 1 is equals negative 3x plus 9. So if you rearrange everything, your 4x is equals to be 10 and x is 2.5. Am I done? Not yet. I have to make sure that this point is right. How I can do that? Put 2.5 over here. You do have 1.5 for your y. Put 2.5 over here and you will have 1.5 for your y. So you know for a fact that this one is going to be the right answer itself. So thank you guys for being here with me. Again, we were talking about graphing, how we can draw that, especially when we were talking about the 2 lines. We are talking about the condition, actually 3 conditions that what would happen to 2 lines. Either they're going to have 1 intersection, no intersection, or infinite number of interceptions. So please like and share and comment if you like this one. And my name is Mahmoud Kiasari. Have yourself a great day, night, whatever. See you around.